Welcome to the Winter Precipitation Types module for ForecastBuilder version 10.8. I'm Ted Ryan, the Science and Operations Officer at the Fort Worth Weather Service Office. This video is part 1 that covers winter precipitation operations, and it is for sites that are not using snow level grids. It is recommended that you have already reviewed the Warm Season Precipitation Types module and feel comfortable with that functionality before beginning this module. Winter weather in ForecastBuilder is more complicated than warm season weather, but a little investment learning how to work with the new tools will yield you with some powerful methods to get the grids to align with the winter forecast that you need to communicate. Before we begin, I want to highlight what is new with ForecastBuilder this winter. Many improvements were made to ForecastBuilder based on feedback from last winter from around the country in various winter weather situations. And now that we know the strengths and weaknesses of the NBM 4.1 probability of weather type data, we're in a better place. Those improvements are new tools to edit the NBM probability of weather type grids to match the forecast. There are better and more advanced tools to edit the weather type grids. New in this version, the precip and accumulation steps have been combined into the same step. Weather type grids will now influence accumulation ratios and mixed precipitation events, which was a common field request last winter. And finally, there were several improvements in the logic of how ForecastBuilder creates weather type grids from the NBM probability of weather type grids that will reduce inconsistency errors that required forecaster attention last year. All in all, I think you'll be much happier with this version of ForecastBuilder this winter. In this module, we will first talk about NBM probability of weather type, or POT grids, and how and when to edit these in the Analyze Adjust step. We'll go over the precip type step, its GUI, and the options when it's in winter mode. This means we'll discuss initializing winter weather types and the options to control these and how various accumulation grids are created. We'll spend some time talking about editing weather type grids and consistency checks. Finally, we'll touch on some optional configurations along the way and talk about how NBM temperature probability data is being used to transition grids away from being purely deterministic. Let's get started. The precipitation type forecasts from the NBM are called POT grids. There's one for each type: POT rain, POT snow, POT freezing rain, and POT sleet. The values of these grids are actual probabilities of experiencing precipitation of that type. Note that doesn't necessarily mean getting measurable precipitation of that type. It just means that the model is directly outputting that precip type. So rather than using an algorithm to determine precip type in a model that may or may not be precipitating, which is prone to a lot of problems, using direct model output from over 100 ensemble members means that significant improvements in POT accuracy and performance have been seen. Here is an example of an NBM POT snow grid. The values in excess of 90 are an indication that over 90% of the NBM's members are outputting snow. Lower values, like 25%, mean that only a quarter of the NBM members produce snow at that grid point. The data can be a bit noisy with some artifacts. In ForecastBuilder, you will see a smoother version of this data as long as you're not in a mountainous region. The raw data will sometimes show large blocky squares, which is from the coarser ECMWF ensemble. The good news is that this will be fixed in the near future. Here's an example of a raw POT sleet grid from the What's Up viewer. The cams in the short term will sometimes output sharper, spottier gradients, while global inputs to the NBM forecast will be smoother and blockier. In some ways, one can look at these POT grids and know when cams are forecasting something that perhaps global models aren't, and it can help you in your forecast process. The key points you need to know about the POT grid forecast are the following. POT grids are used by ForecastBuilder to create weather type grids and ultimately weather grids for the point-and-click ZFP worded forecast. 15% is the magic number you need to remember, and I'll say it again, 15% is a critical value on a POT grid. Values more than 15% and a POT more than 15% allows a weather type grid to be created for that precip type and the precip type step coming up next. The ratio between all of the POT grids are used to split up the QPF for accumulation when multiple precip types are forecast. For example, a POT rain of 40% and a POT sleet of 20% and a POT snow value of 20% means that only a quarter of the QPF will be used for sleet accumulation and a quarter of the QPF will be used for snow accumulation. Half of the QPF will be rain and thus will run off. Having good pot grids means that you'll have good weather type and accumulation forecasts as well. In other words, garbage in, garbage out. So ensure your pot grids aren't garbage, that they generally match your forecast thoughts. Finally, running the weather preview and accumulation preview in the Analyze Adjust step before you start any grid editing is highly recommended. Populate the pot grids in the Populate step to get the latest NBM data by checking them on. Some sites have a cron that does this for them. If there were no major changes from the NBM, the forecaster may wish to leave the previous pot grids in the forecast. Note that populated pot grids are now automatically smoothed in areas with limited terrain by ForecastBuilder during the population step, so they may look different if you're looking at what's up versus what you see in GFE. When you interact with the pot grids in the Analyze Adjust step, you can easily scan for periods when the NBM is forecasting certain types of precipitation. Here's what these grids will look like after populating, and note that long pot grids are a sign that a precip type is not being forecast by the NBM. They're all zeros, so you just get one giant grid with a value of 0. In this forecast, you can see pot rain is broken up, meaning that values of pot rain are changing at each time step, meaning rain chances are forecast. Here's an example of data in all 4 pot grids at every hour. This is certainly a sign that the NBM is forecasting a mixed precipitation winter event. The million-dollar question is, when does one edit pot grids? When the forecasts from the NBM are poor, i.e. they're not matching current observations or trends, or it doesn't match the forecast that you need to communicate. Now, there are some tools that can do some common editing of pot grids. Likewise, this winter, you can use the WRAP and HRRR pot grids if the NBM is not handling rapidly changing short-term trends. So do those artifacts on the pot grids matter? Well, sometimes they do if they're around that critical 15% value. We will spend the next few slides talking about pot grid editing situations. When wouldn't you edit the pot grids? If you're fine-tuning the changeover timing at a precise location of a precip type at an important city or task site, then those changes are often best made in the precip type step, since those tools in that step are better suited for that type of fine-tuned tweaking. Otherwise, if you know you're going to omit a precip type from the forecast altogether, like you don't want freezing rain or sleet, then don't even worry about editing the pot grids in this step. Ignore it altogether or set it all to 0. Some additional notes. Don't delete pot grids, since this can cause some weird interpolation issues to show up at times. And if you're wondering about what happens when the NBM doesn't forecast a precipitation type and the forecaster adds pops, well, there is an algorithm in ForecastBuilder that will assign a best guess pot in the integrity step so that the precipitation type is defined everywhere on your grid domain where pops are forecast. When starting the Analyze Adjust step, before deciding whether you need to edit pot grids or not, I would highly recommend you run the Weather Preview button. This can show you what the combination of the NBM pot grids and your forecast grids are going to forecast for the weather type. The color bar matches the colors off the NWS and DFD webpage. Remember, if you see an undefined color scale, that's because pops are forecast without a defined pot value. You can define one manually, or you can trust the algorithm to pick one for you in the integrity step. Like the weather preview function, the accumulation preview is super helpful to see how much ice, snow, and sleet are going to result. Accumulation isn't only a function of pot grids, it also uses the effects from your temperature and dew point forecast grids. It calculates wet bulb temperature, and also QPF. So changing any of those grids can affect accumulation. Remember, the ratio of pot grids between each other control how QPF is split up. So as you're editing, you can see if you're getting the desired accumulation amounts that you want. Note the preview contains a suite of storm total grids as well. The accumulation preview will also create another grid if some of your snow amount is being reduced or melted by warm temperatures. In this situation, you will get a temporary grid called snow amount reduced due to warm TW. It will show you the grid points at each hour where it's too warm to get the full snow amount potential. Of course, there's nothing wrong with the snow being reduced by warm temperatures, but sometimes that's not exactly what we want, and the NBM can be a little warm when precipitation is actually occurring. Clicking the Nudge T Down button to limit the snow amount reduction will nudge your temperature grids down a degree or two with each click whenever pot snow is forecast. Doing this will result in much more accumulation. Again, running the accumulation preview button, you can see just how much snow you're getting in this now colder scenario. What about the artifacts on pot grids? The bottom line, though, is not to worry too much about these artifacts, but do generally concern yourself with where the values are near 15% and higher. That's where the precipitation type would be mentioned in the weather type grids in the next step. Smoothing these grids can often reduce the jaggedness of where weather starts and ends. Also know that the ratio of the pot grids values will be used to split up the QPF to create sleet, snow, and freezing rain accumulation in the precip accumulation step. What this means is that pot grids will all be normalized, and if half the pot value is sleet and the other half is snow, then the QPF sent for sleet and snow accumulation will be split in half. If you're worried about how noisy this data looks for accumulation purposes, also don't be. These are 1 hour grids, and testing shows that accumulation over 6 hour chunks, it all evens out. If you're worried about how the NBM is forecasting too much of a precipitation type that you don't think will happen, and you need to forecast more snow or ice or whatever, then just adjust the values of these pot grids up or down. One common and easy way to edit pot grids is to use the pot grid adjustment buttons to shift pots from one type to another. Models often struggle with upper level ice nuclei availability. Therefore, the button Increase Ice Nuclei shifts pot freezing rain to pot snow. Likewise, Decrease Ice Nuclei will shift a portion of pot snow or pot sleet grids to pot rain and, if necessary, pot freezing rain. The buttons nudge these values and can be clicked multiple times and will only operate on the highlighted time range and active edit area region, kind of like a smart tool. Let's discuss making some meteorology-based changes. For instance, if a forecaster believes there will be a quicker transition from sleet to snow in this area, or maybe this area is currently getting ground truth reports saying that it's occurring, then they may want to update the grid here to lower the pot sleet values. After the grids are normalized by ForecastBuilder, it would send more of the QPF to snow accumulation. Some examples of other large-scale changes you may make may be shifting the band of snow or sleet in time and space based on the short-term forecast data by editing the pot grids directly. But how would a forecaster make these large-scale changes? Again, you can just use standard GFE tools to adjust the pot grids. This might be using edit areas, pencil tools, or limit value tools. Since I'm usually only editing for this in the short term when NBM pot data is hourly, I would edit at the select hours and then interpolate in between. Remember, the idea here is to make large-scale, meaningful changes, and most of the time this kind of editing is not needed at all. The Analyze Adjust step is just part of the precipitation type forecast process. Don't forget to use the weather preview again after edits are made to see if the desired changes are satisfactory to you. At the precip type step, we will have another opportunity to make changes, and this is where we can do some things like fine-tuning of specific grid points and easier brute force removal or additions of precip types. Since this comes up a lot, the surefire way to remove freezing rain from your forecast is to do it in the precip type step. That's because pot rain and pot freezing rain probabilities are kind of combined into one behind the scenes and then are split up between rain and freezing rain based on your temperature forecast grids and temperature probability grids from the NBM. Thus, you could set pot freezing rain to 0 in the Analyze Adjust step, but any values in the pot rain occurring where your hourly temperature is below freezing or the NBM is not forecasting temperatures above freezing means that freezing rain will come back into the forecast in the WXZR grid. Here's a quick review of the precip type step. Again, remember the purpose of this step is to provide the forecaster more control of the precipitation types and develop the accumulation forecast. In the warm season, there really is nothing to do in this step other than initializing your WXR and pot thunder types. But obviously with winter weather, you will potentially have up to 6 weather type grids that need to be created. The winter weather types are WXZR for freezing rain, WXIP for sleet, WXS for snow, and WXZL for freezing drizzle. Remember that since your final weather grid is created from all of these grids, your POP at each time will have the same value in at least one of the corresponding weather type grids. Drizzle and freezing drizzle weather types are special because they can both be a measurable precipitation type or a non-measurable precipitation type. They don't have to match your POP, but at least one weather type grid during that time period needs to. Here's a review of what the GUI looks like in the warm season. The steps in the winter months are all still the same. 1, you're going to hit the init weather type button. 2, you're going to make any edits if necessary. 3, you're going to fix consistency issues if necessary. 4, again, optionally, you can check the weather preview button to make sure everything looks good. And 5, you can run accumulation, again, if necessary, before hitting save and continue. However, when temperatures are less than 40 degrees in your forecast period, you will see more options show up in the GUI for potential winter weather functionality. There's more weather types to potentially initialize. There's snow, freezing rain, sleet, and freezing drizzle all show up. On the right side, there's a forced snow option that now displays. Finally, most offices will have NBM temperature probabilities turned on. And if so, there's an option in the lower right Fixed Tools section to toggle this on and off. For the remainder of this module, we'll discuss the default initialization of weather types and the basic operations. The Part 2 video will dive into forced snow and the other tools in this step. When you enter this step, the default is to initialize all weather types. If the NBM isn't forecasting any winter precipitation in your area, essentially nothing's going to happen, so you can leave them all selected most of the time. It's okay. Unselect a default type if you know that the NBM is forecasting a type that you don't want in your forecast at all. This is kind of like a hard override and can sometimes create some consistency issues we'll need to fix later. But version 10.8 of ForecastBuilder is actually much smarter on inferring what the forecaster is trying to do and automatically share some of these pots to fix these issues. Drizzle and freezing drizzle are treated as one weather type in the initialization step and then split based on forecast temperature grids. These aren't addressed separately like the rain and freezing rain are. So what kind of weather situation would you omit a precip type? In the extended, when uncertainty is high and the NBM pot grids are forecasting rain and snow and sleet and freezing rain, but you don't want to mention all of them, and you would rather just say a chance of rain and snow. This could also be true if you have the NBM trying to forecast a few grid points of a weather type you would rather not mention at all. These kinds of inconsequential precip type forecasts can easily be omitted in this step. Remember, you can use the edit area and time range options to change your initialization parameters in time and space. So if on Monday you want to initialize a certain set of grids, but on Tuesday you want something else, use those buttons. Here's the initialization logic that ForecastBuilder uses. Weather type at a grid point won't occur unless temperatures are appropriate for that pot forecast. This uses the forecast wet bulb temperature calculated from your temperature, your dew point, and topography grids, and the NBM temperature probability data to make the determination of whether a precip type is legal. It will automatically melt pot snow and pot freezing rain to WXR, or the rain grid, if forecast temperatures are too warm. New in ForecastBuilder 10.8, there's some smarter logic that will eliminate more inconsistencies by inferring the weather situation and what the forecaster is attempting to do based on their initialization options. After initialization, if an inconsistency exists from no weather type being defined at a grid point where pops are forecast, it will try to initialize again. You'll see this message about auto-correcting weather type inconsistencies with modified pot values. If only rain and snow are selected for initialization, it will use values from the pot sleet and pot freezing rain as if they were all rain and snow values. If ZR is selected, it will change pot rain to WXZR if it's cold enough. Testing in various patterns and regimes has found that forecasters like this logic, as the issues it's correcting are usually random and rogue grid points where the NBM precipitation type is essentially a noisy forecast. So let's talk about some more difficult winter weather situations with perhaps all 4 precip types coming into play. In general, the weather type value will match your pot value anywhere the pot values are more than 15%. The initializations in a complex, messy winter precipitation event will do some logic to assign pot values to only the precipitation types that are dominant, and it will demote precip types to a slight chance or secondary precip type if they don't make up a significant part of the probability spectrum. If one precip type has more than double the probability of the next precip type, the lesser type will be assigned a flat value of 15% in your weather type grids. So, for example, if pot snow has a value of 60%, but pot freezing rain has a value of 25%, then WXZR gets demoted to 15%. You'll see this demotion on weather type grids as an area of 15% or a blue ribbon around those weather types. The advantage to doing this method is twofold. We will get simpler wording for the weather grid. It'll just say a slight chance of freezing rain. The other advantage is that you can look at one weather type grid, like the freezing rain grid here, and know that freezing rain isn't the dominant precipitation type that's forecast in this shaded area. There's one or more precipitation types that are most likely. In this case, both rain and sleet are the dominant precipitation types because they match the pop value. As a forecaster and grid editor, you will know you can remove freezing rain in this area if you don't want it without creating a consistency issue later. We'll talk more about this in the part 2 video. Let's go over the length of the weather type grids. This isn't necessary for you to know, but it will likely remove the mystery of why you have some weather type grids of 1 hour and other types you'll have 3, 6, or even 12-hour grid lengths. Generally, the length of the grids are set by the length of your pop grids, but they are combined into up to 12-hour chunks if and when they are the same. During winter weather, weather type grids are also controlled by surface temperatures when they cause a change in precipitation types. However, ForecastBuilder doesn't use hourly temperature grids through the entire 7-day forecast to show this changeover. This temperature grid temporal resolution is 1 hour for the first 24 hours, 3 hours through 84 hours, and 6 hours after that. So if you're looking at a point and click or other graphic for IDSS, you'll get specific hours of precipitation changeovers in the short term. You'll get less specificity in the extended periods. In the case of a switch from a rain to freezing rain in the extended forecast, both WXR and WXZR will be forecast for the same grid at the same time if the hourly temperature in that window is both above and below freezing. This will give the point and click forecast rain and freezing rain in the evening. Here's an example of the varying grid lengths you'll get with a forecast of min and max temperatures alternating between freezing with pops in the forecast. Notice that the weather type grid generally match the pop length in the short term because these hourly pop grids are different at each time step. For the first 24 hours of the forecast, or until 18Z tomorrow, you'll see that although the pops are 3 hourly, the weather type grids are still hourly at times. That's because the hourly temperature is warming above freezing, so you'll get hourly resolution of the changeover from freezing rain to rain across your CWA. After 18Z tomorrow, it will then be more than 24 hours in the future. The temperature grid now is only as specific as a 3-hour window for that temperature change, so your grids will be 3 hours in length. At this point, if we were to look at these weather type grids, you would see rain and freezing rain forecast for some of the same points, which signals that during that 3-hour period, the temperature will both be above and below freezing, so both weather type forecasts are valid. Finally, you'll see that WXR is combined into 6-hour grid tomorrow night and 12 hours after that, only because the smaller resolution WXR grid were identical and it could be combined into a single grid. This combining means that there are fewer grids for you to scan because they don't have a change in them. NBM pot grids are probabilistic and forecast temperature grids are deterministic. This will naturally create some incompatibility. There are legitimate forecast reasons why one could have a forecast of a low probability of liquid rain even though the most likely forecast temperature is below freezing. This would be because most model solutions are dry and sub-freezing, but a few are warm and rainy. ForecastBuilder will use NBM temperature probability data to QC your forecast grids versus your weather type grids. In some cases, it will control how the pot grids initialize your weather type grids. This means a forecast of liquid rain below 32 degrees is a legal forecast. If this causes messaging issues in your area in some situations or you just don't like it, you can turn this off by unclicking the Use NBM T Probabilities option under the Fix Tools menu to revert to a purely deterministic forecast of your temperature and dew point grids. Finally, I'm going to plug using the Weather Preview button here too. It's super helpful in messy winter situations where the final weather grid is too cluttered or messy to read. This grid will color your precipitation types. You can use this for IDSS, like phone calls, to easily step through the grids to see the exact timing of changeovers. Clicking the Run Accum button in the Accumulation section of the GUI will create the following winter accumulation type grids. Here's a brief description of where those accumulation values come from in ForecastBuilder. For each winter type, you need to have a weather type forecast for that location or you will not accumulate that precipitation type. As already discussed, the amount of QPF distributed to each accumulation type depends on the ratio of all the pot grids with each other. Hitting the Calc Ratio Pop button will display those informational grids for you if you desire. For ice accumulation, the FRAM algorithm is used, which uses forecast, wet bulb temperature, wind, and a 1-hour QPF. That 1 hour QPF is derived behind the scenes if your office doesn't forecast 1 hour QPF. Line ice is a radial ice conversion of the ice accum grid, and flat ice accumulations are equal to the ice accumulation grid. They just have a different name to remind us of what we're forecasting. Sleet amount uses a default SLR, or snow to liquid water ratio, of 2, while snow amount adds up the sleet amount forecast, uses the snow ratio grid for the SLR and the QPF product. A special snow melting algorithm is used when temperatures are above freezing to tamp down on accumulation at warm temperatures. Here's an example of the grids displayed after hitting the Calc Ratio Pop button. This button is for informative purposes only and viewing how the QPF is split up between the weather types. It's helpful in mixed precipitation events. The ratio type grids show the percentage of QPF going to each precip type. The Pop type grids show the pop value associated with each precipitation type. Editing these grids will have no impact on anything. They are just for viewing. If you don't select the Run Accum button, a pop-up will appear asking if you want to run it as a reminder. There may be situations where you change the weather type grids but want to keep your accumulation grids as is. So you can skip this by clicking on either the skip button or the left side of the menu navigation bar. On to consistency checks. This slide is a review from the warm season module. Consistency between your weather type and your pop grids are still a critical component, since pop and the weather type grids need to match at every time range, and forecasters could inadvertently create a mismatch between the two. In winter weather type grids also need to match other forecast variables like temperature. Winter weather type consistency also includes temperature inconsistencies with weather type. Snow, sleet, and freezing rain can't occur at unrealistically warm wet bulb temperatures. You can't forecast snow with a wet bulb temperature of 55 degrees. Likewise, rain can't occur if you don't have above freezing temperatures possible in the forecast. As an example, essentially the issue is that you may forecast warm temperatures in the Analyze Adjust step at some grid points, but in the Precip Type step you may also forecast snow at those grid points. Of course, this is probably an inadvertent oversight on your part, but it's inconsistent. You can't forecast both, so you'll have to tell ForecastBuilder which one has the priority. Like pop and weather type inconsistencies, you'll have a button pair to pick from when there's an inconsistency. Either you can fix or force your temperature to weather type, or fix or force your weather type to temperature. Some common inconsistencies that show up in the real world are that the forecaster wants to remove freezing rain and or sleet in the extended forecast, so they don't initialize those types. But that was the only precip type that the NBM was forecasting at some grid points. Another situation that comes up a lot is that the NBM forecasts snow, and the forecaster also wants to forecast snow, but the forecaster didn't realize the surface temperatures were above the snow wet bulb temperature threshold. This commonly happens because the NBM is applying a bias correction from a series of warmer and sunny days, but this bias correction isn't appropriate for a snowy day forecast. If your foundation grids are all perfect, then the precip type step will take less than a minute. However, we often find things that we'd like to change or inadvertently create inconsistencies that we're not aware of. The tools in the precip type step often make it much easier and faster to make these changes than redoing our foundation grids and then rerunning the precip type step initialization again. The next training module, or part 2, is demonstrated on how to use these tools in weather situations you may find yourself in. Learning them may seem overwhelming now, but mastering them will save you time in the long run because they unlock some powerful editing modes. As always, the ForecastBuilder team uses your feedback and ideas to make the software as good as we can. Please consider contacting us for any questions or suggestions that you may have. Thank you.